spin up Gaia chain, osmosis chain, or a custom chain of your own, bring your own binary, whatever that is. You can set up layers between these chains, spin up an explorer, spin up a chain registry service, and get the whole thing working. So got this working with mesh security. So by the end of this workshop, we'll spin up 2 chains, run all the smart contracts on those chains, and then that will do mesh security. So quickly go over the some more details on the configuration path. So if you specify the type to be custom, then you can use your own binary images. And images, Docker images are where we manage like different versions of chains and stuff. So you can specify some more information around like initialization, and a lot of it goes through the chain registry. So and the base like glue code that we have is around spinning up more number of validators, and we use a Cosmos.js faucet to basically spin those up, initialize themselves as a validator, and they start themselves, talk to Genesis. So we use port forwarding. Port forwarding is something that.
Can you show a link to the docs?
Oh yeah, it's starship.cosmology.tech. So actually, there's a get started page which will help you start with the dependencies, and I think that's something that you need to get started. So we have a bash script that does the whole dependency installation. So you can try and install that on the system, follow it, or you can just have a look at what you do. So this is it. So what are the dependencies? So we use Docker. We need kubectl. kubectl is the Kubernetes CLI to interact with the cluster. Kind is something that you can spin up your local Kubernetes cluster on Docker. And then you have Helm, which is the package manager for Kubernetes, and YQ, which is like JQ for parsing YAML files. You mostly would need to use kubectl for most of the debugging. All the other things are abstracted out in like commands and stuff. You don't need them. You don't need to interact with them. kubectl is nice because then you can get the logs and all these kind of things. I'll go over how to do that. Cool. Once you have all the dependencies installed, then you need to connect to a Kubernetes cluster. So there are a couple of ways. You can spin up a kind cluster, which will spin up a small Docker cluster in a Kubernetes cluster on a Docker container, and it will just emulate that. So there's a very simple command to do this. So it's kind create and create a cluster. If you're using Docker desktop, and I think that's what most people would use on Mac anyways, there's a way to enable Kubernetes, and that will spin up like Kubernetes on your Docker location. The last part is like connecting to a Kubernetes cluster, so you can also connect to a remote cluster. Not part of this, but and then once you are able to connect, then you can do get kubectl nodes, like make sure that you're connected and stuff. So I'll just run some of these commands right now, and then so in the Starship repo, we have examples. We have a bunch of examples there. There's a getting started one that we'll go over in this one. Yeah, so I'm just leaning into it and show you guys the concrete part. Cool. So this is what we'll spin up. We'll spin up an osmosis node, single validator. Actually, we'll spin up all things. One Cosmos chain, Gaia chain, and a Hermes layer connecting the two. By default, we create an IDC transfer channel between them so that we can use the connection with clients for like other stuff. And we'll spin up an explorer and a chain registry. So just this. Okay. So connected to a Kubernetes cluster running in Singapore right now. Oh, this is running mesh, so it's already running something. I'll destroy this and then replace it. So we have a make file as well that has all these commands, handy commands. In the getting started example, you can have a look at that. Yeah, we'll do it now. So we'll install the time chart and then run the config path against it. It's telling me some errors around the namespace. I'm just changing the namespace. So, starting to create these resources, we have 15 resources spinning up bunch of things. Quickly go over what we are. We don't need to wait for them until they. Yeah, so you can see that there's a bunch of pods spinning up. So we have the Explorer, Gaia chain is already up and running. I like K9S as the base. Okay, Yes. So yeah, so we have a Gaia chain trying to spin up. The three pods here. One is a validator pod. We run an exposer, which just allows you to do like some extra stuff that the validator usually doesn't allow. We spin up a Hermes relay, and the third one is a CosmJS faucet. So the Genesis node will run a faucet next to it. Other validators, when they spin up, they won't have a faucet. They'll just use the Genesis faucet. And we spin up our chain registry services. Takes some time to spin up. Once everything is running, then we'll do port forwarding and we'll have everything globally. We can check the logs. Yeah, all the chains. Logs are being produced. These are all running on a Kubernetes cluster in Singapore. So yeah, it's not running on your local pod. We'll wait for the Hermes alert and then we will command will get all this local. Cool. So everything seems to be in a running state. So we do make port forward, and we will port forward all the endpoints locally, and you can see there's a nice way to. So we'll just go. So Explorer is spun at localhost 8080. We spin up Tinkoff right now. We want to support more Explorers. Get this is Tinkoff. So you can see there's a Gaia chain, there's an osmosis chain. On the osmosis chain, you can see everything that basically builds nothing. So currently there's just one validator. You can see that. You can see see logs being produced, transactions, stake, how much validator has how much stake, everything. And the other chain is also there. So cool. This is nice, fine, I guess. But what I really like is the chain registry. So let's just do Kubernetes. So run a service similar to the chain registry. We follow all the schemas and stuff, and you can get all the information about the denom, about the whole chains here. The cool thing is you can also get, we scrape the IPC information as well. So any connections that is being created between the chains, we scrape them, put it in this schema. So when we create more channels, they are also available. And you can write test cases now more easily because you have all the information that you need anyways. The other thing is we also expose some of the mnemonics. So chains. This is the chain registry, and if you do keys, this is an extra thing that chain registry doesn't have, of course. But we also have the mnemonics of the Genesis stuff. But we also run a faucet, so you can just query the ask the faucet to give you when you're writing your test cases. Cool. So we'll do one more thing. We'll just spin up more number of validators. I think that's because that's part of Kubernetes stuff. So currently we are running one validator on each chain. We'll spin up like more.
Oh, really? There we go.
Cool. So we have like 5 validators for each chain now starting up. So firstly, the Genesis nodes for each of the validators start up, and then all the other validators start themselves up. So this is a nice way to have the whole multi-node setup be running. Again, we spin up the Explorer, or maybe the registry should take less than 1 minute. Less than 2 minutes. Also, you can run like any number of chains as long as you have resources for it. So, currently we have 8 VMs. Instances right now.
Definitely not.
Some of them are sorry. we also have a GitHub action runner. It's not documented yet, but everything that we run we do OwesomWasm. And it's basically we have a GitHub action runner, so you can give it the same config file you're using, and you can just visit that and we'll run it in the client cluster on the CI, or we can connect to a Kubernetes cluster remotely and run it and get. Okay, cool. We have like 10 nodes up and running. Like bringing more to and then now the hooking is there also up and running. So we have it in a ready state.
You're not expression. No. Let's see you're when somebody yeah. Can't do my credentials. Like well, it's still, you know.
So you can see that there are 5 aggregators, all producing blocks, all running. Yeah, for osmosis chain. Currently, we are creating the state from scratch, so it is empty state with some initialization, but we quickly have so we have the ability to have snapshots from any. So we can start the chain from any Genesis. We can start from our Genesis. IBC connection. IBC connection between osmosis that we are running and your Sky chain is already up there. You can see that. Cool. That's about I'll quickly just spin up what we have for mass security and
basically then it's the first then we then it's something.
So for mass security, we are running like 2 chains. One, both of them are using custom mesh security SDK chain binaries, and that's what we currently use for development. So we split these 2 chains up. We do rename some of the denoms to Juno so that yeah, we can get that done. Once Osmosis and Juno support this, we just have to change the image to just point to a Osmosis image and Juno image, and we have the whole setup still. We can specify the resources that we are providing each of the nodes, and we can specify the videos well. And we have a type server. Again, this configuration is expandable, and so if you specify type service load balancer, then you can spin up an actual load balancer in the Kubernetes cluster, and then you can access these endpoints not just by local port, but and also so yeah, it's pretty expandable. We have a bunch of documentation around what everything already means, but and this one. We're working on using RC version of Snapchat. So there are four consumer nodes and four provider nodes, and it's for relay between that chain registry spun up. So while this spins up, I'll quickly go over the test. Set up it. Okay, these are end-to-end tests. So currently we have them in Go, but we want to quickly have them in Kotlin.js so that you can use it for front-end devs. And we'll also have them in Rust. So smart contract developers don't need to change languages. We can, and since this is end-to-end, interacting with the system, it can all be any language that you want. So a lot of these tests is like unit tests that we just ported to mesh security, so it's not still ready, sort of, but it's an weekly structure. We have a setup of sorts, that mesh security setup function. This setup will initialize all the contracts and do things required. And then we have test cases after it that will like query the value in the set on those two contracts, and then ensure nothing is staked by virtual staking contracts, and then the provider chain has some test of deposit, some address the deposits and tokens on those wallets, and then we make sure that we check that it is actually being staked. Again, these tests are like unit tests that have been ported to Starship, so most of this work has been done by Alex. We just ported it to run against our infrastructure. So as you can see, everything is up and running, and we'll quickly just set up the contracts.
I think that it was stopping.
So. It's more changes.
It's sort of motion like that.
So we do need to run code forward before we run the test because we're running this. While this is running,
I get one.
Good. How's the episode? Do you like it by the
Yeah.
You can run those data get logs. Like you can see if it's already. It's actually the amount of care. Until it is running. Not just covering.
I had the same thing. No, I had, but when I exited the thing, I saw more than just gives me some darkness.
Very simple.
Sometimes when you walk out, you're like, ah,
Very small. Yeah.
no, I miss it.
Sorry.
Hey, you know, like, I don't know. You think like more 8 or 6, but
Well, they fly.
take your train.
Because they. Like a buggy fern. Now you need to. Build down.
It's also I've actually got for door.
Yeah, I think I'll be. No, still like. That's what you said. You're gonna make conflict with them.
Yeah, like I don't necessarily fall down.
You just check out the documentation and if you have any questions yourself, so we have a bunch of GitHub stuff.
Be really strong. Sometimes. Like,